Hello Pokitto users. I have been hard at work making EEPROM saving scheme for the Pokitto. So this is a very requested feature. The idea here is that you can have several games and applications that all store data into the EEPROM memory in a way that when you shut down the device, the memory is maintained, the data is kept. And I have called this system the Pokitto cookie system because cookies are maintained in browsers between sessions, and here the idea is the same. So in this demo, which is already available in the Pokitto GitHub repository, along with an example of how to use it, you generate data like this. So you press A and it generates random data. And in this random data we have a player with initials UQX who has gotten 12 points. His rank is expert, playtime so and so, and then there's a long blah blah text that is needed to show you how the cookie system operates. But what's interesting in here, and maybe more interesting for the developers among the Pokitto users, is that there's a EEPROM view that I've built here so that you can actually see how the system operates. So in the beginning of the EEPROM system we have a key table, and keys are 8-character long ID keys that identify the cookie. And we can see that in this system there are 3 cookies, and you can have up to 48 cookies, and this demo program only shows the first 12 because the 48 won't fit on the screen. So we have a numbers cookie, we have highscore test cookie, and we have yogi save cookie. By pressing sideways you can actually go through the different blocks. It's a little bit difficult to see here, but there's a change of color. So if we look at block number 0, we can see that block number 0 in the block reservation table is owned by a cookie called numbers. And this block only has, or this cookie only contains 5 numbers that are 16-bit long, or sorry, 32-bit long numbers. So 1, 2, 3, 4, and 5. Okay, and if we go to cookie, or we go to block number 1, we can see that block number 1 is owned by cookie number 1, the highscore test, and it's also shown highlighted there. And as we go through this, we see that block number 1 actually contains the data that we saw here in the other screen, so UQX12. So you can actually see that this is where the data is stored. So block number 1, all of the blocks are 32 bytes long, and you can see the entire block at once, and there are 112 blocks. So what the system is really nice about is that first of all you can have numbers, you can store numbers, or you can store characters, you can store floating point numbers. All of the cookies extend the base cookie class so that it gives you a tremendous amount of flexibility. But what's interesting is that now cookie 1, which is the highscore test, is actually 4 blocks long. So you can see that this data that starts with this is extra long text that is needed to waste fill cookie memory. So you can see that this string extends past several blocks and ends over here. And finally in block number 5 we can see that we have the yogi save cookie that only contains the text yogi bear. Now what this system does is when we generate any kind of data and we store it, now the new highscore holder is WMP, we shut off the system and we reboot. Oops, sorry, I pressed reset by mistake. We can see that the data is maintained, and we go here and we can see that it's over here. You can delete the cookie while the program is running, so I press B to delete the cookie, and you can see that the cookie disappeared from the key table. So the highscore test cookie disappeared, and you can also see that the blocks 1 to 4 are now free, and you can see that they are now available for another cookie. If we want to regenerate the cookie while we're running the program, we just go here and generate new data, and it gets stored into the cookie memory. We have BKL14, who is a rookie, and if we go now back to the cookie table, we see that the cookie high score test has been regenerated. You can see that the 4 blocks that were in between have been reserved back, and the blocks can go jump over other blocks, and the system can use any blocks that are available. This window only shows the first 21 blocks because I can't make all the blocks show here. But there's quite a bit of memory, and you could basically have 48 cookies at the same time, 48 different programs taking up different areas of the memory with different kind of data. So this is still under development, but it works already pretty well. I'm going to upload the binary of this program into to our talk.pokitto.com forums, and I'm also have updated this demo and its source code into the GitHub repository. So I'm hoping that everyone tries out how this new EEPROM saving system works, and reports of any problems if they see any. I'm going to make an easier version of this demo program for people who are not so interested in how the backend system of the block saving thing works, because at the moment the demo program is quite complicated, because it includes all of this this logic of showing how what is the content of the EEPROM. But I will make a simple example so that you can see what is the simplest way of storing some data, for example high scores for your game. Thank you for watching. We'll be back with more later.